Hi everyone, in this video I will explain given matrix A how to find its higher powers. Let us take one PYQ. For matrices A is equal to 3 minus 4, 1 minus 1 and B is equal to minus 29, 49, minus 13, 18. If a to the power of 15 plus b into xy is equal to 0, 0, then among which one of the following is true? This problem was given on January 21st, 2026 in shift 2. See there, matrix A was given, there you have to calculate a to the power of 15. Generally such problems are based on mathematical induction. Now see the procedure how we can calculate higher powers. So first I am writing the given matrix. Given matrix A is equal to, that is 3 minus 4 1 minus 1, that is the given matrix. Next I am calculating A square. So matrix A square is equal to A into A. So that becomes 3 minus 4, 1 minus 1 multiplied with 3 minus 4, 1 minus 1. Just I want product of these two matrices. See the product now. 3 into 3 becomes 9. 9 minus 4, that is 5. First element is 5. See the next element. 3 into minus 4 minus 12. Minus 12 plus 4, that becomes minus 8. Second row. 1 into 3, 3. Minus 1 into 1, minus 1. 3 minus 1 becomes 2. So this element is 2. 1 into minus 4 is minus 4. Minus 1 into minus 1 is plus 1. Minus 4 plus 1, that becomes minus 3. So I calculated A square. To identify the sequence among the elements, let us calculate A cube also. So A cube is equal to, we know, A square into A. For A square I am writing this matrix. 5 minus 8, 2 minus 3 multiplied with A. For A I am writing 3 minus 4, 1 minus 1. See what is the product of these two matrices now? So this is equal to 5 into 3 becomes 15. 15 minus 8. 15 minus 8 becomes 7. This is next element. 5 into minus 4 becomes minus 20. Minus 20 plus 8. Minus 20 plus 8 becomes minus 12. Next row. 2 into 3, 6. 6 minus 3 becomes 3. 2 into minus 4 minus 8. Minus 8 plus 3. This is minus 5. So I calculated A square and A cube. Now see the sequence among the elements. With the help of the sequence, directly I can write A to the power of n. See now how I am writing A to the power of n. In A to the power of 1, first element, here 3, here A square. In A square it is 5. In A cube it is 7. 3, 5, 7. So 3, 5, 7 are in the arithmetic progression with common difference 2. What is the nth term? For nth term, Tn is equal to A plus n minus 1 into D. So that becomes 2n minus 2 plus 3. That becomes 2n plus 1. that is the first element in a to the power of n. See the next element. In a to the power of 1, this element is minus 4 into 1. In a square, this element is minus 4 into 2. In a cube, this element is minus 4 into 3. Therefore, in a to the power of n, I can say it is minus 4 into n. That element was generalized. See next element. In a to the power of 1, this element is 1. In a square, this element is 2. In a cube, this element is 3. Therefore, in a to the power of n, this element becomes n itself. Next, see last element. In a to the power of 1, this is minus 1. In a square, it is minus 3. In a cube, it is minus 5. Minus 1, minus 3, minus 5, etc. are in the arithmetic progression with common difference minus 2. So what is the nth term? Tn is equal to a plus n minus 1 into common difference is minus 2. So opening that bracket, it is minus 2n plus 2 minus 1. That becomes minus 2n plus 1. That is the last element. Generally, whenever if you want to calculate higher power of the matrix, generally that depends on mathematical induction. That is one of the important methods in mathematical induction. Because I got a to the power of n, now I can write down a to the power of 15. First I am calculating the matrix a to the power of 15 plus b there. So for matrix a to the power of 15 plus b, this is equal to, write n is equal to 15. It is 15 into 2, 30. 30 plus 1 becomes 31. Minus 4 into 15 becomes minus 60. See the next element. N is equal to 15 was given. So this element is 15. N is equal to 15. Minus 30 plus 1. That becomes minus 29. So that is the matrix a to the power of 15. For a to the power of 15, b should be added. So matrix b, it is minus 29, 49, minus 13, 18. So what is their sum? See now. Sum of the matrices, here itself I am writing 31 minus 29. 31 minus 29 is 2. Minus 60 plus 49. That becomes minus 11. 15 minus 13 becomes 2. Minus 29 plus 18. That becomes minus 11. So I calculated a to the power of 15 plus b. Let us take the given matrix equation. Given matrix equation is a to the power of 15 plus b multiplied with the column matrix xy. This is equal to column matrix 0, 0. That is the matrix equation. For a to the power of 15 plus b, I calculated 2 minus 11, 2 minus 11. This matrix is multiplied with xy. This is equal to 0, 0. So expanding that, 2x minus 11y is equal to 0. So first equation will become 2x minus 11y is equal to 0. Expanding along the second row, 2x minus 11y is equal to 0. We got the same equation. 2x minus 11y is equal to 0. Again we got the same equation. Both the equations a and b are same. Geometrically, these equations are representing straight lines, coincident straight lines passing through origin. These two equations are geometrically representing two straight lines which are passing through origin. Therefore, every point on the straight line is solution. They will be having infinite number of solutions. They will be having infinite number of solutions. Every point on the straight line is solution for them. Now let us identify which option is the correct option. Because it is having infinite number of solutions, we have to identify in the given 4 options which option is becoming solution. Just I am verifying. For x is equal to 5, y is equal to 7. 5 into 2 becomes 10. 10 minus 77 not equal to 0. So this is not satisfied. This is not correct option. Check second option. X is equal to 8, y is equal to 11. 16 minus 121 not equal to 0. So this is not correct option. X is equal to 11, y is equal to 2. 11 into 2, 22. 22 minus 22 becomes 0, satisfied. Therefore, C option is correct option. Here I am giving 2 recent PYQs. Practice yourself. For more videos, subscribe.